Welcome to the video. We are going to solve flatten a binary search tree to sorted list. In this question, we are given a binary search tree, okay, and we have to flat it okay, into a linked list with the given condition that left child should not point to anything. It should point to nothing. Okay, points to null. And the right child points to the next element in the sorted list of elements, which means see left does not have to point to anything. Otherwise, the inbuilt function, the machine code will return us -1, okay, and we'll get an incorrect result. But the right child should point to the next element, next sorted element. Okay, so see in example one, you have this binary search tree, and the flattened version of it, the flattened linked list version of it will be this one output 2, 3, 4, 5, 6, 7, 8. So the left child does not point to anything, and right child should point to the next sorted element. Next sorted element. Similarly, in example 2, you can see in this BST, left point does not point to anything and right points to the next sorted elements. How we will do it? We will use a dummy node first of all and a depth first traversal. Okay, dummy node and a depth first traversal in order to accomplish it. So first of all, I will create a dummy node head, okay, value 0. Now this dummy node which created is created with the value 0. Now this dummy node will serve as the head of the resulted sorted linked list. Okay, this is initialized with a value that's lower than any value in the binary search tree. Okay, the value will start from the 1. See the data of the nodes, it starts from the 1. Okay, so that is why I have used 0 to initialize it, so that it is always smaller than any other probable elements which will come in this linked list. Cool. Now I will use a utility function, or let's say recursive function, to flatten the linked list, flatten the binary search tree. How will I pass it? First of all, I will create a function travel, okay, the helper function, and I will pass root as the current element and head as the node in which I will just pass further. Okay, so this function will be called with the root of the binary search tree and the dummy node which we just created. This dummy node will act as the starting point. Okay, now after the traversal will get complete, we will return the right child. After the traversal is complete, this function travel returns the flattened linked list starting from the node immediately after the right, immediately after the dummy node. Okay, immediately after the dummy node head which we created, because we do not need it. We just used it as a utility point in order to construct the further linked list from the flattened version of BST. Okay, cool. Now, how we will imply this function? Let's write the code for that. So I have named my function travel. Okay, it takes two value, root and head. Head is one such thing, but root I will rename it to node in this for this function inside function. Okay, now if not node, return head. What it does? So it takes the current node. If the current node is none, which this means we have reached the end of the subtree. If the current node is none, which means we have reached the end of the subtree, then we will return the current head of the linked list. We'll return the current head of the linked list. Okay, okay. Now we will recursively traverse left subtree and right subtree of the current node. Okay, left is equals to node dot left, right is equals to. Before traversing further, we will disconnect the right child and the left child of this particular element, this particular node. Okay, we'll disconnect the current node from its left and right children by setting the value of their references to the none. And how do we reference? We reference using the dot left and dot right property. Okay, so node dot left equals node dot right equals none. Cool. We just disconnect all the references of both the left subtree and right subtree, left child and right child. Cool. Now after traversing the left subtree, we will append the current node to the end of the flattened left subtree. What this will give us? This will help us achieve no, this will be achieved by finding the rightmost node of the flattened left subtree using recursion and setting its right child to the current node. Okay, let's see how I do it. To travel left comma left is the current node, append it. Okay, before but what we did, we appended the current node to the end of the flattened left subtree. We flattened the left subtree here using this function. We flattened the left subtree here and added the current node, okay, to the end of it. Okay. Okay. Now after this, we will just return the last node of the flattened subtree. We will return the last node of the flattened subtree. Okay, which is the current node after it has appended. Current node after it has appended to the end of the subtree, end of the left subtree. Okay. Now right, comma, node. So it does the function. Let me again reiterate what it does, and let me submit it and check. By the time I will just reiterate what this function does. Okay. So first of all, we used okay, we are getting okay. For this, I will just employ this one. So we have increased the recursive depth limit of our Python function. Okay. Now our function recursively traverses the binary search tree and flattens it into a linked list. How it does? Our travel function takes two arguments: node, which represents the current node, and head represents the head of the resulting linked list. Now, if the current node is none, which means the end of the subtree has been reached and it will return the current head of the linked list. Cool. Otherwise, it recursively traverses the left and right subtree of the current node. Before traversing further, we will disconnect the current node from its left and right children by setting their references, which is dot left and dot right, to none. Okay. After the traversing of the left subtree, we will append the current node to the end of the flattened left subtree. Okay. How we will do this? We will do this by finding the rightmost node of the flattened left subtree. Okay. Using recursive calls and setting its right child to the current node. Now finally, this function travel returns the last node of the flattened subtree, which is current node, after it has been appended to the end of the left subtree at the end. We just return it. I hope you learned a new concept, you enjoyed it. Thank you. Have a nice day.